Jai Ho students, welcome back to SCSC's Digital Media class session. Dear students, in previous class we have discussed the first property on whole numbers, integers and rational numbers, that is closure property. Clear? So what we have discussed? Closure property of whole numbers, closure property of integers and closure property of rational numbers. Clear? Now we have to discuss the second property, that is another property, that is commutative property. Commutative property of whole numbers. Today we have to discuss commutative properties of whole numbers under addition, under subtraction, under multiplication and under division. So we have to study the commutative property of whole numbers under addition and subtraction. Yeah. So here commutative property we have to apply for whole numbers. Yeah. Here we have a general formula for commutative property of whole numbers under addition. It means what commutative property states. If you add, so what operation we have taken? Addition. If we add any two whole numbers in any order, clear? Then their sum is always same. For example, just look at one example. 2 is one whole number. Yes. 5 is another whole number. What about their sum? Sum is 7. Sum is 7. First whole number is 2, another one is 5. Their sum is 7. Is that 7 a whole number? Yes. Now you can add them in a reverse order. Reverse order in the sense, first you take 5, then you take 2. Then means 5 plus 2 is also 7. If you add any two whole numbers in any order, we obtain the same sum. Sum is same. That is what we can say a commutative property. Yeah. So shall we write the general formula for this? We can write for every A and B. A and B, what are those? A and B are the whole numbers. They belongs to W. They belongs to W. So both the whole numbers. So here what we have taken? Addition operation. Then A plus B is equals to B plus A. That is also belongs to W. So it is W. Clear? So if you add A plus B, that is first whole number and then second whole number, their sum we have to see, and second whole number and first whole number, their sum we have to see whether they are same or no, whether they are equal or no. That gives what we can say a commutative property. Yeah. So let us take one example. Let A is equals to 17. A is one of the rational whole number. Next, and B is equals to 6. B is 6. Then what we have to do? We have to follow this rule, commutative property rule. That is A plus B is equals to B plus A. A plus B is equals to B plus A. So what about A? 17 plus, what about B? 6. Then what is B? 6 plus what is A? 17. What is the sum of 17 plus 6? 23 is equals to 23. So both are same. The sum of these two whole numbers, and we have written these two whole numbers in reverse order. Both values are same. Yeah. A plus B is equals to B plus A. This condition is applicable. Which condition? That is commutative property condition is applicable for the addition of whole numbers. It means we have to conclude that whole numbers are commutative under addition. So what is that? Group, finally we can give the conclusion. Whole numbers are which property we are using? Commutative. For closure property, whole numbers are closed. So here whole numbers are commutative. Whole numbers are commutative under which operation? Under addition. Commutative under addition. So this is what we have discussed earlier in the previous classes. Whole, that is closure commutative property of whole numbers. Now under subtraction, what we have to apply? Commutative property under subtraction. We have to use here what operation? A minus B is equals to B minus A. So let us see here for every A and B both are in the set of whole numbers W, then A minus B is not equals to B minus A. A minus B is not equals to B minus A. So this condition is not applicable. Which condition? That is subtraction of whole numbers is not commutative under it is not commutative. Clear? So you can take some examples. Example you can take. Let A is equals to 5 and B is equals to 7. 5 and 7 both are whole numbers. Then we have to apply this condition. This is addition, and for subtraction we have to use this condition. That is A minus B is equals to, just to check whether they are equal or not equal, and B minus A. A minus B is 5 minus 7 is not equals to 7 minus 5. What is the difference? 5 minus 7, it is minus 2, and 7 minus 5 is plus 2. Are they equal? They are unequal. Both are unequal. Both are unequal. It shows that whole numbers are not commutative under subtraction. Therefore, whole numbers are not commutative under subtraction. It means this property, that is commutative property of whole numbers, is not applicable for the whole numbers. Commutative property is not applicable for subtraction of whole numbers. Clear? Next we have to see under multiplication and division. Next we have to apply the commutative property of whole numbers under multiplication. So here we need to write a general formula for commutative property of whole numbers under multiplication. That is for every A and B. For every A and B. So both are whole numbers. A is one of the whole number, B is another whole number. Both are in the set of whole numbers. Clear? And here we have to apply which operation? Multiplication. That is A find the product of any two whole numbers in any order, we obtain the same product. Here, so here we have to take one example. What example we have to take? Let A is equals to 15. A is one of the whole number and B is 5. B is one of the another whole number. Then what we have to use? This condition we have to apply for these two whole numbers. That is A into B is equals to B into A. We need to check whether they are equal or no. Yeah. What is A? 15. What is B? 5. Next B into A. 5 into 15. Yeah. So 15 5s are 75. 5 15s are 75. Yeah. For every whole numbers A and B, A into B is equals to B into A. So both the values are same. LHS equals to RHS. By this we come to know that whole numbers are commutative under multiplication. So what finally we have to give the conclusion? Whole numbers are commutative. Here we are using commutative property. Whole numbers are commutative under multiplication. Whole numbers are commutative under multiplication. Now the fourth operation is division. So commutative property of whole numbers we have to apply under division. So here for every A and B are the two whole numbers. A and B belongs to W. Belongs to W means the set of whole numbers, and A divided by B is not equals to B divided by A. So both the values are not same. So you can take one example. Let A is equals to A is 7 and B is 21. Let A is one last whole number, B is another whole number. Then find their division. A divided by B is not equals to B by A, or no. You need to check it out. Yeah. So what we obtain? 7 by 21. A is 7, B is 21. Is equals to B by A, that is 21 upon 7. Are they equal? No, they are unequal. 7 ones are 7 threes are 7 ones are 7 threes are. So 1 by 3 is not equals to 3 by 1. It shows that whole numbers are not commutative under division. Therefore, whole numbers are not commutative, under division.